In this video, we're going to go through the compound interest problem from the Section 2.5 activity. Interest is when you pay to use someone else's money, and normally it's calculated as a percent of the principal. And if we reinvest interest so that it becomes part of the principal, it will earn interest on itself. And this is called compound interest, and we have these two formulas for compound interest. This box is taken directly from the textbook. So the first formula is A equals P times 1 plus R over M to the MT power. A lot of books will use N instead of M, but this book for some reason uses M. And then the other variables are listed here, what they are. A is the amount after a certain number of years. P is the principal, R is the interest rate expressed as a decimal, so we need to convert a percent to a decimal for that. The M is the number of compounding periods per year, and T is the time in years. So when I'm looking at this, I'll write an N in here just because you might have seen it with an N before. When we're looking at this formula, the values for M could be, if it is compounded quarterly, that means it's 4 times a year, so M equals 4. Monthly would mean that M equals 12. Daily would mean that M equals 365, since there's 365 days in a year. You might also see weekly could be M equals 52, or semi-annually would be M equals 2 because it happens twice a year. Annually means just once a year, so M would be 1. And then we also have the continuous compound interest formula. And so if it's compounded continuously, we use this second formula, which doesn't have an M, and it's P times E to the RT power. E is a number, and it's approximately 2.718. And you can find that number on your calculator. I'll show you where that is on the decimals calculator in a little bit. So what we're going to do for these problems is use the Desmos scientific calculator to solve these problems. The first one, we have $1,000 invested in an account paying 10% compounded monthly. How much will be in the account at the end of 10 years? So first what we need to do is identify what each of our variables are, and then plug them into the formula, the first formula up here. So I'm solving for A. I want to know the amount in the account after 10 years. My principal is $1,000 because that's my initial invested amount. Then I have 1 plus 10% is 10 divided by 100, or 1/10 as a decimal. So I would plug in 0.1 for the R, and then my M is that it's compounded monthly, so M equals 12. And then M is plugged into 2 places in the formula, as you can see down here in the denominator, and then also in the exponent. I usually write parentheses around the exponent because on many calculators, if you try to type this in without parentheses, it doesn't really work right. And then my T is 10 years. So I plug in 10 for T. And then I'm going to go to my Desmos calculator and just type all of this in to find the answer. So easiest way to do it without making a mistake is to use a calculator where you can just type everything in all at once. And when you try to do the exponent here, you'll notice if you try to type just 12 times 10, it's not going to work. I could do that in my head, obviously. I know that's 120, but sometimes it won't be quite so easy to do that mentally. So there's what I get, $2,707.04. And as always, you want to make sure that you are paying attention to how problems want you to round numbers when you're doing the homework problems in MyLab. The second question says, if interest is compounded quarterly instead of monthly, will the amount in the account be more or less than the answer to question 1? So we could calculate this. Instead of 12, we would put 4 in for M. That's actually what we're going to do for question 3. But to answer the question, all we need to do is recognize that the more times that we are compounding, the more money that we make. So if we're compounding less frequently, then there will be less in the account. So I'm just going to type this in here. Compounding more frequently leads to more in the account. So the more frequently that we are putting that interest back into the account as principal, the faster our money is going to grow because we're earning more interest because there's more money in the account. Now it's actually not a very big difference. And we will see how much it actually is going to be here when we do question 3. So it's going to be less than $2,707.04. So for number 3, we're plugging in the same thing that we plugged in for number 1. We're just replacing these 12s with 4s. So I will write that out here. We're plugging in 1,000 for the principal. We're plugging in 10% for the interest rate. And now we're plugging in 4 for M and 10 years for T. And so I can go to my Desmos calculator and just switch these 12s for 4s. And I get $2,685.06. So if I compare that, once I write that down here, $2,685.06 compared to what I got for number 1. It's a difference of 15 plus 7, $22. So a difference of $22 over 10 years. Not a very big difference, but it is a difference. You are making less money if interest is compounded less frequently. And the last question here says to calculate the amount if interest is compounded continuously. So continuously is kind of the important word here. That means that we're using the other formula. So we're using the formula with E instead of the formula with M. So we have P times E to the RT. And the difference with this formula is, aside from not using M and having the E, another difference is that your interest rate is in the exponent. So I'm still plugging in 1,000 for P. Then I'm going to have the E. And remember, E is not something you're plugging in for. It's a constant. My interest rate is the 0.1 or 10%. And then my time here is 10 years. And again, I'm putting parentheses around my exponent there. So to plug this into the calculator, I'm going to start a new row here. I'm going to enter 1,000. And then to find the E button, you can see there's some buttons here, special buttons that you can use, but there's not the E. The E is under the FUNC, which stands for function. There's actually 2 E buttons there. There's one that's E to the X, and there's one that's just E. You can use either one. The E to the X button automatically puts your cursor in the exponent, so it saves you a click, but the E button works just fine too, and then you can go back to main, where you can access the exponent key. So hit the E button. You probably can also use the E on your keyboard as well. And then I'm going to type my exponent here, 0.1 times 10. And I get 2,718.28. And that's how you use the compound interest formulas.